Here in this is the architecture of Abinitio. In the architecture of Abinitio, we have the graphical GDE where we develop our graphs. By using these interface, we develop our graphs, or we can develop .mp files, .pz files, or plans. Okay, here in this, not only .mp, it is just a graphical interface where we develop mp files, .psets, and plans. Here, after developing these mp files, psets, and plans, we will deploy all these things in cooperating system. Cooperating system is the one where actual process will start. After developing all your mp and after developing all your required things, required objects, we will deploy all those things in this cooperating system. And cooperating system, what the cooperating system will do is, cooperating system will compile compile and run that particular graph and convert it from .mp to .ksh. Okay. After converting to the in the respective home directory, we call it as a AB home. We will define AB home in the cooperating system. We will define AB underscore home while installing the cooperating system. In this AB home, it will convert all .mps to .ksh, and it will process our .ksh file. It makes the
Sorry. What is a AB home? I didn't get it.
AB home is called as Abinitio home. In the Abinitio home, what it will do means, it will here in GDE. GDE means nothing but this. Here we will develop some graphs. Graphs means nothing but some. It is this one we call it as a graph. Okay. Based upon your requirement, we will create one graph. Okay, here you can save that this graph as .mp extension. Okay, after saving your .mp extension, while running, if we click this green button, it is called in the running state. While running, it will deploy all your code. This running and all these things will be done by the cooperating system. GDE is nothing but only a graphical user interface. Okay, it does nothing. Here in the GDE, it doesn't do the compilation or it doesn't run. Okay, compilation, I already said, compilation will check whether the graph is syntactically and semantically correct or not. Whether you have given syntax means, first it will check whether you have provided. Here if you see, here there are some yellow colors. Yellow colors means to do the to do list. Here it will check whether you have provided all the required things, like the input file name and the ports. We will discuss what are these ports and what all about all these. But here first it will check syntax and semantic error, and then afterwards it will do the required. It will compile and create a .mp file from .ksh file from .mp file. Not only we create .mp file in GDE, we will create psets and plans. We will let us um, in the further classes, we will see what are these pieces and dot plans. Okay, but what you need to know is, cooperating system is the one where we deploy all our objects, and it will compile and run our graphs. Okay, this is the operating system. Cooperating system may be installed on Unix or Windows. While if you are installing on Windows, here, since ours is a tutorial version, That means if you are trying to install on Windows, it will, I will show you, it will check for NT operating system. Okay, if it is Windows 8 and above Windows 7, it will not accept. Here it is accepting only the NT file system only. Here if you see the error setup requires Windows NT 4.0. Okay. Below Windows 7 we can install this co-op. In the real-time system we mostly install this cooperating system. This is called as host. Host means where we deploy all the things. In the real-time system, we install this cooperating system on Unix. Okay. Here we are not bothering about if it is a single user, it is not connected to a network. We are not bothering about EME. Okay. EME means enterprise meta environment. When this EME comes into the picture means if there are if it is a network and several users are working on it. Here every user have one GDE. Okay. Here every user have one GDE, but the co-op and yeah, every user will have one GDE, and for every GDE there should be a license. Since because it is not a freeware, we have to buy a license for every GDE. Okay, but for cooperating system and EME is a centralized repository. It is a centralized repository where number of users can dump their code in this EME, because you have developed one code and you can dump your code in EME. It is called as check-in process. Okay, and you are dumping your code into an EME process. When the EME comes into picture is if there are number of users only, EME comes into a picture. If you are a single user, EME doesn't comes into a picture. Okay. Here checkout means if somebody has designed some code or somebody has updated the new version of the code, you will do the checkout. Okay. Here if you see the options in the GDE, it is called as check-in and checkout. Okay. Check-in and checkout will comes into a picture when there is an EME. But if it is an single, you are only the single user who is working on this EME and co-op, then this EME doesn't comes into the picture. Okay, this EME doesn't comes into the picture. Mm, okay. Here this EME is called a centralized repository where it maintains versions and it maintains the data, like it maintains the metadata. Here the name itself is meta environment. Meta, here it will says all the users data and the version of different objects. It is also called as mm, here we call it as a sandbox. Project information, it says, and we also call it as version controlling tool, because it is maintaining different types of versions of objects. So we also call it as version control tool. Okay. How we interact with the GDE means by checking and checkouting the objects. Here Here the main benefit of Abinitio is multiprocessing. Here, if it is a single processor, no need of these things. These things means here, if you see, since the benefit of Abinitio is when compared to the Informatica, Abinitio is a multiprocessor tool or multiprocessing tool. Multiprocessing means if you have given any task to the operating system to perform, it can perform singly. If it is an mm, yeah, it can perform we it's our based upon our dependency, based upon our data. We can go for a multiprocessor or a single processor. Here, if it is a multiprocessor, it will assign the task to different types of different processor. Here, suppose if you see here, the operating system is assigning task to processor 1, and here, if I think it is a processor 2, it is called as multi-processing system. Okay. We also here, if it is a not a multi, if there is a small data, if we don't want to go for a multi-processing system, we go for a serial processing system. But since the advantages of Abinitio is a multi-processing system, if you are running with a small amount of data, then there is no actual benefit of using the ab initio. If the amount of data is very small, then uh, there is no point of using ab initio. Okay, if you want to have the license for the ab initio, first they will evaluate whether is ab initio is required for your organization or not. Okay, most of the organization go for a multi-processing system rather than single processing system. We call it as in serial files and parallel files. Suppose if you come here, you can see in the URL you can select whether in the graph, whether in the graph only we can technically say whether your graph need to be run in a multi-environment system or single environment or serial environment system. We will see in our classes how we can in the graph itself how we can made a multi-file and a serial files. Okay, this is regarding a brief introduction of Abinitio architecture. As you see here, the interaction between the cooperating system and EME is again the check-in and check-out. Okay, from the cooperating system also we can interact with the EME by check-in and check-outing the objects. Okay, here the GDE and cooperating system is we deploy all our code in the co-op, and we after deploying, when we are running, it will convert .mp to .ksh, and it will do the required. .ksh means, as I said earlier, it will convert all the MP, that is, you develop all the graph which you developed in the into a Unix script. That Unix script will do the required thing. Whatever you require based upon your requirement, it will do that particular task. Okay, that particular task may be done in an by a serial processor, or that means single processor, or it can distribute the work into a multiple processor. We call it as a serial way or parallel way. Here in the parallel way, we have the different types of parallelism. Different types of parallelism means whether it is in four-way. Four-way means whether the task is performing by four processor, it is a four-way parallelism. If it is the task is performing by eight-way processor, we call it as an eight-way parallelism. Or if the task is performing by 16 processor, we call it as a 16-way parallelism. Okay, 16-way parallelism based upon your requirement, we define the parallelism. Okay, the number of server we need to the task, the number of servers we require to perform that particular task. Okay. Okay. This is all about the Abinitio